Alright, welcome back everyone. So in the last episode, we covered how to draw circles on our canvas in random locations, but that only gets us so far. We only have static circles on the screen. We want to make sure that these things are animating so that we give the user an interesting experience, something that they might not be used to when they visit our site. So how do we get our circles moving on the screen? Well, instead of dealing with all these circles at once, it's going to be easier for us to deal with just one circle and get that thing moving before we go on to moving all of these circles at the same time. So let's go ahead and comment all of the code we have right now out, just so we can focus on that one individual circle. We'll comment out our rectangles, and then we'll comment out our for loop as well. We're commenting this out instead of deleting it because it's going to be useful for us to reference this later on because we're going to be using the same concepts. So if we refresh the page, you're going to see we have a blank canvas, but now we want to actually create a circle that we can get moving and basically bouncing off the sides of our screen. So, as you know, based on the last episode, we can create a circle using the arc method that we have right here. So let's go ahead and copy and paste this. Put that right at the bottom, and then we'll uncomment it out. And then, since our arc is using an x and y variable that we set within this for loop, let's go ahead and give it a hard-coded value of 200 by 200. And if we refresh the page, you're going to see that we have a circle on our screen. Perfect. But now we need to be able to move the circle around. We need to go from left to right, up or down, just something to get it moving. And you may be wondering, well, how do we do that? Well, there's actually a particular method that we need to go about to get the circle moving. And this method is first creating a function. And you can name this function whatever you want. We're going to call it animate because this function is going to be meant for animating. And within this function, we are going to be using another function called requestAnimationFrame. And this requestAnimationFrame function takes another function as its argument. Basically what's going to happen is we're going to use this animate function, and we're going to be putting it within a requestAnimationFrame function's argument. Once we call this animate function, this requestAnimationFrame function is basically going to be creating a loop for us. It's going to say, okay, we want to be able to create a loop basically, and what function do we want to call to loop through? It's going to say, call this AnimationFrame function, and then call animate, and if we call animate again, then it's going to call this function. And we're basically creating a loop. It's basically cycling through these over and over again until we tell it to stop. But this is only going to work if we actually call animate at the bottom of our screen like so. And if I refresh the page on the right-hand side, you're not going to see anything because we don't actually have any data or any input being put into the browser for it to be read. So to put some data in there, we're going to put a console log statement with our animate function. We're just going to console out whatever we want. And if we refresh the page, you're going to see that this is being called over and over and over again. It's just incrementing up, 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 up. And it's going to keep going until we tell it to stop. And there are certain ways to get it to stop, but for the purpose of this video, let's just focus on the basics of getting this thing moving. So to get this thing moving, it's going to be good for you to understand how animation works in general. Animation works by refreshing the page. We're basically going to be refreshing the page, and each time we refresh the page, we're going to be moving the circle's x and y value incrementally by very, very little. So we're basically going to be refreshing the page, and then we're going to be incrementing our x value by 1. And as we increment it by 1, the circle is going to move over to the right by 1. And we're just going to keep doing that over and over again. And it's going to give us the illusion of animation. It's going to look like the circle is moving from its current location all the way to the right hand of the screen unless we tell it otherwise to do so. So if we want to be incrementing our x value for our circle, it only makes sense for us to grab our circle code and place it within our animate function. So if we put this within our animate function and refresh the page, you're going to see that we now have a bold circle. That is because the circle is being drawn on top of itself over and over again. We only have x and y value of 200 by 200, and since it's in the same spot, we're just drawing the circle on top of itself. But we want to make sure that we're changing these x and y values correspondingly so that they're not stuck at 200. We want to make sure that when the page refreshes itself, it's 200, and then it's 201 when it refreshes again, then 202, 203, and so forth. And once we do that, we're going to get the illusion of animation. So whenever we want to change a number, we need to create a variable, and we're going to declare this outside of our animate function, and this is going to be called variable x. We're going to set it equal to 200. And so instead of using 200 within our x value for arc, we're going to use our new x variable, and then we're going to add 1 onto the current value of our x variable each time the page is refreshed. Each time this animate function is called, we're adding 1 onto x. And once we do that and refresh the page, we can now see that our circle is moving from the left to the right-hand side of the screen. but we're actually creating lots of circles in the process, and the circles are being drawn on top of each other, thus creating this line from the center circle of the screen all the way to the right side. Now, how do we fix that? Basically, what's happening is we're not actually clearing the canvas each time the page is refreshing, each time our canvas is refreshing. So we need to make sure each time before we call an arc that we are clearing the canvas using a c.clearRect method. And this is the same thing as the fillRect method that we used up here earlier. It's going to take an x value, a y value, a width, and a height. So we want to make sure that we're clearing the entire canvas from 0, 0 to the canvas's width to the canvas's height. So we're going to say 0, 0, inner width, inner height. So this is going to clear the canvas for us each time we want to draw on top of it. And once we refresh the page, now you can see that the circle is not being drawn on top of itself over and over again. We have this nice circle being created for us because we're clearing the canvas each time this animate function is being called. So this is only getting us so far. Right now, our circle is going off the screen, and we don't really want that. There's no use of it going off the screen because we can't see it. Let's go ahead and make it so that once it hits the side of the screen, it bounces backwards, and then once it hits the left side of the screen, it bounces backwards as well. So it's going to be bouncing back and forth from the left and right hand side of our screen. In order to do this, we need to make sure that we have a conditional for our x velocity. So right now our x velocity is 1, and if you're unfamiliar with velocity, basically it is the speed, it's the rate at which something moves in a particular direction. So right now we're moving our x coordinate at a speed of 1 pixel each time the animate function is called. And it's moving in a positive direction, so therefore our velocity is 1 pixel per frame refresh to the right. Now, since we want to make sure our velocity can be negative or positive, we're going to want to create a variable for that as well. So our variable is going to be called dx, and that is just a standard acronym for our x velocity. And this is going to be equal to 1. So instead of adding just 1 to our x value, we're going to be adding dx to our 1 value. And play around with this a bit. Go ahead and change this value. If you see we change it to 4, it moves a bit faster, our velocity is higher, but we're going to stay at 1 for the time being. Maybe we'll change it up a bit once we want it to hit the right-hand side of our screen quicker than just 1. So we know we have a velocity of 1, but we need a conditional that says once our x value is equal to the inner width of our screen, go ahead and change our velocity to a negative value. So we're actually subtracting a negative number from x. We're actually subtracting 1 from x, which causes the circle to go from the right-hand side of the screen to the left-hand side of the screen. So to write a conditional for this, we're going to say if x is greater than the inner width of our screen, make dx negative. Go ahead and switch the value of dx to a negative number. And let's go ahead and watch what happens when we do that. Let's go ahead and amp this up to 4. And with that in place, you're seeing that it's bouncing off the right-hand side of the screen. But if we look closely, you'll see that the edge isn't bouncing off the side of the screen. It's actually the center of the circle. We want to take into account that our circle has a radius and that the edge of the circle should be bouncing off the screen and not the center of the circle. So we need to say if x plus the circle's radius, and our circle's radius is equal to 30. But let's go ahead and create a variable for that right now. Our circle's radius is going to be equal to 30. So we want to say if our x value plus the circle's radius is greater than the inner width of our screen, then go ahead and bounce it off. And I need to save that. And there you go. So once the edge of the circle hits the screen, we're now reversing the velocity so that the circle is going from right to left instead of left to right. But once it hits 0, you can see that it keeps on going past the width of the browser. So we also need to take into account that conditional as well. And we can add an OR operator in here. And we can say if x minus the radius of the circle is less than 0, then go ahead and do the same thing. Go ahead and reverse the velocity of our circle. And let's see if that works. Perfect. So now we have a circle that's bouncing from the right and left-hand sides of the screen. But we also want to make sure that the circle is bouncing off the top and the bottom of the screen. So right now we have an x value which is being varied up, but we don't have a y value which can be varied. Right now it's a hard-coded value of 200, so we want to make sure that we have a variable which can be set and changed up in the process. So we want to make sure that we have a y variable. This is going to be equal to 200 as well to start. And we're going to also need a y velocity. So we're going to say var dy is also equal to 4. And then now that we have a variable for our y coordinate and also a variable for our velocity, we now need to make sure that we're adding our velocity onto our y coordinate. So we're going to be adding our dy onto that. And with this in place, you're going to see our circle is moving diagonally, but once it hits the bottom of the screen, we're not actually bouncing anywhere. We want to make sure that once the circle plus its radius hits the bottom of the screen, that it bounces upwards, and then once it hits the top of the screen, it bounces downwards. So we need to do the exact same thing that we did for our x and inner width values. So all we're going to do is add another conditional, and we're going to say if y plus the radius of our circle is greater than our screen's inner height, then we are going to reverse our y velocities direction. So dy is going to be equal to negative dy. Let's test that out. You see it bounces right there. Now we just need to add the or operator, so we're taking into account what should happen when circle hits the top of the screen. So we're going to say if y minus radius is less than 0, reverse the velocity as well. So now you see we have a circle that is bouncing off the top, left, right, and bottom of our screen. Cool. So let's take this one step further and randomize the velocity of our circle. We'll also randomize the position. So whenever our circle is spawned, it's going to be put in a random position from left, right-hand side of the screen. And it's also going to be traveling in a different direction each time the circle is spawned. So you'll see right now, if I refresh the page, the circle keeps going from right here to a diagonal direction in the bottom right. Each time I refresh, we want to make sure that the circle has the potential to be spawned anywhere and go in any direction on that spawn. So there's a little bit of math involved with this, but nothing too hard. Let's go ahead and get started with that. So right now our x and y value is set to be a hard-coded value of 200 by 200. But this isn't random at all. We already know it's going to be over here. So we need to add what is known as a math.random function. And this math.random function, all it does is it generates a random value 0 through 1, as we covered in the last episode. So we want to make sure that we get a random value from the left-hand side of the screen to the right-hand side of the screen. So we are going to multiply this by the window's inner width. And then for our y value, we want a random value from the top and bottom of the screen. So we're going to multiply this math.random by the screen's inner height. So that'll give us a random position each time we refresh the page, but it doesn't actually give us a random velocity. Technically, whenever a circle is spawned, it's going to be going from somewhere over here to a bottom right direction. So we want to randomize our dx and our dy value so that dx can be negative or positive. That way, once the circle is spawned, dx, if it's negative, it's going to be traveling to the left, and if dx is positive, it's going to be traveling to the right. Same thing with dy. If dy is positive, then it's going to be traveling downwards. If dy is negative, it's going to be travel upwards. So how do we make sure that we get a random value that's either negative or positive? Well, we are going to be using the math.random function again. So this will give us a positive value each time. We get either 0 through 1. All we need to do to make sure we're getting a negative value is subtract 0.5 from this. And if you think about this, math random, the greatest value you can get with math random is 1. So if we get 1 and subtract 0.5, our greatest value is going to be 0.5. But the lowest value math random can get is 0. So if we get 0 and subtract 0.5, we are going to get a lowest value of negative 0.5. So that's how this works. We can get either a negative or a positive value just using this simple arithmetic function right here. So we want to make sure that we're doing this for a y value as well. And with this in place, we should see some randomized velocities. And there we go. It's a little slow at the moment, but we can go ahead and amp this up a bit. Let's go ahead and place these in parentheses. And let's multiply this by, let's just say, a factor of 3. And that should speed things up a little bit. All right, it's a little faster. Let's go ahead and amp it up a little more. Let's hit up 8. There we go. Okay, we're getting some speed here. So as you can see, sometimes it's fast, sometimes it's slow. That's because we're getting a random x and a y value. If we want it to be something like 4 to 8, a random speed of 4 to 8, well, there are certain things we can go about doing that. But for now, let's just keep it simple. Know that this is how you get either a negative or a positive value, and you can amp up the speed of it by multiplying it by a factor. That way you can get either a value of 4 to negative 4 using what we have here. All right, so we know how to animate a circle. We know how to bounce it off the edges of the screen. But sometimes you see that the circle is stuck on the edge of the screen, and there's a reason for that. It's because the conditionals are interfering with the spawn location of the circle. And it's hard to get it to randomize on the edge of the screen, so we're not going to worry about that just yet. What I want to show you guys is how to create multiple circles that have their own independent x, y values, independent velocities, independent radiuses, radii, so that we can create multiple circles on the screen, have them all go in different directions, bouncing out the screen independent from each other. So how do we go about doing that? Well, if we wanted to create another circle here and have all the same functionality that we have going on right now, well, there's quite a bit that would go into that. We would need to create another arc function, and we need to create a whole nother set of variables over here so that we can have a new math random for our x, a new math random for our y, a new math random for our velocities, and so forth. And we'd also need to include conditionals for all of those new variables, and that can get really tedious in the code, and that's just not good practice because we're duplicating our code, and we're also repeating ourselves over and over again. So to alleviate this, we're going to be using object-oriented JavaScript. And we're going to start off by creating a JavaScript object. And that JavaScript object is going to be a circle. So this is how you create a JavaScript object with JavaScript. You're going to create a function, and that function's name is going to start off with a capital letter to indicate that this is an object. So we have a circle object, but the circle object is going to need its own independent x and y values. Each of our circles is going to be placed in an individual spot, separate from one another, so we need to make sure each circle has its own x and y value. So to give each circle its own x and y value, we're going to say that this x is equal to x. And where do we get this x value? Well, we're going to be passing it through our circle function each time we instantiate a new circle. So each time we create a new circle, we're going to pass in an x argument. This x argument is going to travel right over here, and we're going to be setting this circle's x to whatever value is passed through. And we're going to do the same thing for our y value. We want to make sure that our circle has its own independent y value. So we're going to say that this dot y is equal to y, and then we're going to create an argument for our circle called y like so. So we have a way to set our x and y values for our own independent circle, but right now we don't have a way to draw this. These x and y values are kind of worthless if they're not being used anywhere, so we want to make sure that we're creating a method within our object, and this method is going to be called draw. And instead of being equal to a property like this, we are going to be setting this equal to a function, an anonymous function. It doesn't have a name, it's just going to include whatever contents are inside of it. So within this anonymous function, what's going to happen is we're going to draw the circle whenever this is called. So let's go ahead and instantiate a circle real quick so you can get a better idea of how this is working. We're going to create an object, a variable to be exact, and this variable slash object is going to be called circle. And this is going to be equal to a new circle with an x value of 200 and a y value of 200. This is how you instantiate an object with JavaScript. You precede the function name with new, and it's going to store all of these properties and methods within the circle variable. So if we wanted to fire whatever code is within this anonymous function, within this draw method right here, let's go ahead and add some dummy code here. If we wanted to call any of this, fire this draw function, well, we would take our circle object and we call the draw method at the end of it, and that's really all we have to do. If we refresh the page now, you're going to see that this function is being fired. If we comment this out, function is not being fired. So we want to make sure that whenever this is fired, right here, this draw function, that we're actually drawing a circle. So we can go ahead and grab our draw circle code right here, replace the console log with it. And now if we draw out our circle, okay, you're not seeing anything as of yet. And that is because we still have our animate function running, and our animate function is clearing the screen each time the frame rate is being refreshed. So the circle.draw function is outside of our animate function. Let's go ahead and throw it in there so we can actually see it. All right, so there's our circle. We created a circle, instantiated it, stored it within a circle object, and then we actually drew it out on screen with this method that we have right here. So right now this is a static circle. This is what we had early on within the episode, but we want to get it to the point where it's bouncing out the screens moving like this circle right here. So how do we go about doing that? Well, instead of just having just one draw function, we're going to be including an update function. And this is going to be equal to an anonymous function as well. And we're going to include the same code that we have right here for our velocities and all of the conditionals to switch up the directions of our velocities. So let's go ahead and take this. Our circle's not going to animate anymore, as you can see. Let's put it within this update. All we need to do now is we need to tweak a few things here. First, we need to make sure that each individual circle has its own x and y velocity. So we're going to say this.dx. is equal to dx. And since we are bringing in a dx right here, we need to make sure we're passing it through as an argument, which means we also need a dy for when we include this .dy right beneath it. So we have x velocity, we have a y velocity. Each individual circle is going to have its own independent from one another. And now we just need to reference these within our update function. So right now, these are referencing random variables. We need to make sure that they're referencing the circle's properties. So we need to prepend all of our velocities with this. All right, so right now our circle doesn't have its own radius independent from one another. Right now we're still referencing the radius that is down here. So we want to make sure that we also give our circles their own radius, which can be referenced separately from any other circle. So this dot radius is going to be equal to radius. And since we're including this right here, we need to make sure that we have an argument within our circle. And that's going to be called radius. All right. So we want to make sure that now that we're creating a radius property for our circle, that we are prepending all of our radiuses, radii, with this. That way we're referencing only this specific circle's radius. All right, so let's go ahead and refresh the page and see what we get. Right now, we're still getting the same circle that's being randomized within our animate function. Well, why isn't the circle being drawn? Why is that? Well, part of the reason might be because we actually forgot to reference our properties within this arc right here. How was that being drawn beforehand without these being referenced? I'm assuming that the x and y values are being referenced from these x and y values down here, but I'm not entirely sure. So we want to make sure that we're referencing the circle's properties right here instead of the x and y variables that we declared previously. So we also want to make sure that we're referencing the circle's radius. And if we refresh the page, still nothing. And you can see we created a few new arguments for our circles. So we need to make sure that we're filling all of these out. We have an x argument, we have a y argument, we have a dx argument, we also have a dy argument, and we also have a new radius argument. So we need to make sure that we're filling each of these out. We know that we want to create our circle at 200, 200. Let's go ahead and give our x velocity, started out on 3. Same with our y velocity. Let's give this a radius of 30. Refresh the page. Okay, so now we have our circle being drawn, which is pretty cool, but it's not moving as of yet. And that's because we're not actually calling our update function. We need to make sure that we're not just calling our draw function, but we're also calling our update function. So let's replace circle.draw with circle.update. And still nothing. Now our circle isn't even being drawn. And that is because only our update function is being called instead of our draw function. We want to make sure that we're first drawing out the circle and then we're changing all of its properties. Once we draw the circle, that's when we can actually change the properties and have the circle move across the screen in different directions. So we can actually call this method within this update method. And all we need to do is say this, .draw. And excuse me, I actually put this in the wrong spot. As you can see, this .update only goes from here to here. We need to make sure that we're including this draw function within our update function. So if we put that there, refresh the page, you can now see we're in progress again. We actually have a circle moving that's updating and bouncing off the sides of the screen, independent from any other circle that's being drawn. So let's go ahead and get rid of this static circle, this kind of hard-coded circle that we created within all of this other stuff. Let's take this code, paste it at the top so we can use it later. We're going to want to randomize our values. Let's just go ahead and comment this out for now. And let's go ahead and delete this code right here. So all we have is our circle bouncing off the sides of the screen. Okay, perfect. And since we had all this randomization up here, let's go ahead and integrate that into our code really quickly. So I know I just said put it up top screen and comment it out, but let's go ahead and put it right above our circle so we can get to using some of these functions that we have here. So if we were to get this one circle randomized, then we can go ahead and comment all this out and insert all of the respective values within the respective positions. But we want to be creating multiple circles on the screen. So in the last episode, we covered the for loop. And we know that the for loop is meant to loop through something a certain amount of times, a pre-specified amount of time. So we're going to be creating a for loop. We're going to say var is equal to 0. And we want to run through this 100 times. So we want to be creating 100 circles, basically. We're going to throw our circle instantiation within this for loop. And we want to make sure that we're creating 100 circles and storing them within one variable. And to store 100 circles within one variable, we are going to be creating an array called circle array. And to create an array, this is all you have to do. You just have to assign your variable to some brackets. So this is going to store all of the circles that we create. So to actually store new circles that have independent values within this array 100 times, what we're going to do is we're going to create a new line within our for loop. And circle array is going to push a new circle each time this for loop is ran through. So we can actually get rid of this code right here. And we want to make sure that all of our values are randomized each time this for loop is ran. So we're going to grab all of the code we have right here, put it within our for loop, uncomment it, and now we can use all of these values each time we instantiate a new circle. So the circle is going to have a random x value, a random y value, a random x velocity, a random y velocity, and it's going to have a static radius since radius is hard-coded at the moment. So what's happening is we're creating 100 circles, each with their own individual random x, y, x velocity, and y velocity coordinates. It's going to be different each time because math random is going to produce a different value each time this for loop is ran. So we have our circle array, and since we deleted our circle variable, let's go ahead and delete this right here. If we refresh the page, you're not going to see anything because we're not actually drawing anything within our animate function. But if we console log out our circle array, you're going to see that this array is full of 100 circles. And we can open these up, and if we look at our first circle, you'll see that dx, dy, x, and y have very randomized values. And if we look at our second circle, you'll see that this has different dx, dy, x, and y values from everything else. So all of these circles have different values that are independent from one another, which means they'll spawn in different locations and move in different directions. But how do we actually get these drawn on the screen? That is the next question we need to answer. So to get these drawn on the screen, we are going to be creating another for loop, but this for loop is going to be inside of our animate function. And we're going to start things off the exact same way we did up here. Now technically we could say 100 right here, but usually it's best practice to declare how long your array is dynamically. So basically what this is going to do, it's going to return the length of our array, and you can see our length is 100. If we were to add more circles into this, then it would automatically update this length to something like 101, 102, 200, 300, and so forth. So basically, we're getting the length of our array automatically rather than hard coding something out like 100. So we're going to say circle array dot length, and all this is doing is saying run 100 times since the length of our circle array is 100. And that's exactly what we want because we want to be able to access all of the individual items within our array. And to access all of the individual items within our array, we need to first access our circle array, and then access each individual index by using something like 0, 1, 2, 3, 4, 5, and so forth. But instead of typing that out manually, we're just going to throw our I in here. And since our for loop is running repetitively over and over again, it's going to be running through all of our circles within the array automatically for us. And since it's doing so, basically what's happening is the first time this loop gets called, we're accessing our first circle, and our first circle has an update function. So we are going to be calling update on it. And then automatically it's going to go to the next circle, call update, the next circle, call update, and it's going to do that until it reaches the very end of all of our circles. So if I refresh the page now, you can see we have circles being spawned in different locations, being moved in different directions all over the place. And this is kind of crazy right now, so let's go ahead and down our velocity a little bit. And that's a lot more smooth. That's a lot better looking than it was before. Alright, so right now our circles are being spawned to the point where their radii are getting caught in the left and right hand side of the screen. Same thing goes for the top and bottom. We want to make sure this is not happening. We want to make sure our circles are only being spawned within the canvas's coordinates, the canvas's inner boundaries. So to make sure that this is happening, let's go ahead and move our radius to the top of our for loop, because we're going to be using it within this x and y setting right here. And instead of spawning our x value in a random coordinate from 0 to the site's inner width, we need to make sure that we're spawning it in a random coordinate from 30 to our inner width minus the diameter of a circle. And what that's going to do is it's going to prevent the circle from getting caught on the sides. It's only going to be spawned in a location in which it can ensure the circle can bounce off the sides of the screen. So we need to first subtract our circle's diameter from the inner width of our coordinates. And to do so, we're going to say radius times 2. And we're going to wrap this in parentheses like so. And that should prevent them from getting caught on the right-hand side of the screen. But now you can see they're still getting caught on the left-hand side of the screen. We need to take that into account as well. So we want to make sure that our x-coordinate is greater than our circle's radius. So to do so, we're going to say add the radius onto the end of this value right here. And if we do that, Now you can see we're not having an issue with the left and right hand sides of our screen. The circles are no longer getting caught there. But the circles are still getting caught on the top and the bottom of the screen, so we need to take into account that as well. So we're going to be altering our Y value so that our inner height only has the possibility to be 0 from inner height minus the circle's diameter, which is going to be 60. So radius times 2. Throw that in a parenthesis so that can compute. So we're not having an issue with the bottom of the screen, but once this computes, we want to make sure that our circles are going to be spawned in a location that's greater than the circle's radius, so they're not getting caught on the top. So to do that, all we're going to do is add circle's radius onto that. And now you can see all of our circles are being spawned, random locations, random velocities, and all inside the canvas coordinates. So that's a lot to cover. We just covered object-oriented programming, animation, velocity, x values, some math with math random, getting these things to spawn in different coordinates, making sure that they're not spawning off the screen. We also covered conditionals, a lot to cover in one episode. So don't feel bad if you're not getting everything right away, guys, but really focus on the main subjects that we covered. I want you guys to take it really easy, experiment with all this, change the colors of these. You can get some really cool effects going on just by changing colors, the velocities, the speeds, and so forth. Let's go ahead and change the color to our circle within our draw method. Let's go ahead and give it a fill. C.fill. Save that. You see that we already got a pretty cool effect going on with our black background and our blue border. Go ahead and play around this a lot. Go ahead and use squares, lines, and so forth. Anything you'd like to use. See what kind of stuff you can come up with. Go ahead and leave a comment with your work. I'd love to check it out. If you need any help, code reviews, or so forth, let me know. I'd be more than glad to help any of you. But anyways, this is already a lot to cover in one episode, so I hope you guys enjoyed, and I look forward to seeing you in the next one. We're going to learn how to interact with these based on event listeners with mouse movements and also touch movements on your phone. So I hope you guys enjoyed, and I look forward to seeing you in the next episode. Later.